Hi, I'm Craig. Let's talk about cars. Today we're talking about drivetrain assemblies, and today we're going to learn a little bit about theory and operation for rear-wheel drive shafts, rear-wheel drive axles and differentials, limited slip and locking differentials, 4x4 systems in operation, and front-wheel drive drivetrain. So, rear-wheel drive shafts. Basically, the last thing we talked about was transmissions, specifically automatic transmissions. So up until this point, we've discussed the internal combustion engine, how we make power, and all of that intricacies to make a little shaft turn out of the back of the engine, and that goes into a transmission, which you see in this picture right here, and that basically is there for the gear reduction or overdrive, depending on what purposes and load the vehicle is being operated under. Well, now, how do we get the power out of the transmission and then down to the drive wheels? And that really depends on if it's a rear-wheel drive platform vehicle or a front-wheel drive platform vehicle. So first we're going to talk about a rear-wheel drive platform vehicle, and basically you have this drive shaft, or also known as a prop shaft. And this is what connects the back of the transmission to the differential. This drive shaft has to accommodate different heights and different lengths. As we'll talk about, it does this via a simple U-joint. Well, it's one component that helps do this. So this simple joint has a driving yoke and a driven yoke, right here, and then this cross in the center. And this is a simplified animation or cartoon version of a U-joint, but this is basically the device that allows the drive shaft to bend and move as the differential goes up and down over bumps. So here's an actual kind of blown up diagram of the U-joint. So here's these yokes, or in that previous pictures right here, you've seen that kind of a cartoon yoke and a cartoon cross. Right here, here's the actual cross, and the little trunnions is bearing right here, and then you have the yoke right here. This is the one that goes into the differential. This front slip yoke, and this is what goes into the transmission. Now this particular drive shaft, this slip portion right here is what goes in the transmission around a seal, and it allows for the differentiating lengths on that drive line as it goes up and down over bumps to accommodate for suspension travel. And that's what these U-joints right here and the cross center sections allow. They allow the drive line to accommodate different angles as the differential goes up and down. This slip yoke allows the drive line to become shorter or longer as the differential goes up and down. So what's a U-joint? Well, basically, again, you have the cross. This big chunk right here, it's hollow. You get grease fitting right here, a Zerk fitting. And then you have a trunnion where these needle bearings ride, and then there's a bearing cup where these other needle bearings ride in between. So this is kind of like the bearing cup's kind of like the outer race, and this trunnion's like an inner race. And then of course the seal right there. And then here's the slip yoke that I'll show you that accommodates the different lengths of the drive line. Again, it can be external or internal, that slip yoke. So here's kind of a side view of what I was talking about, that the drive line has to accommodate different angles and different lengths based on vertical travel, suspension travel. So as you go down the road and that rear tire goes up and down with suspension, that drive line is going to get longer and shorter based on the vertical travel of that differential. As it goes up and down, the operating angle is also going to change. What's important to note is that this angle right here is equal, this bottom angle on the front is equal to the top angle on the back. Or it's allowed to be within a certain variance to eliminate vibrations. Here's an actual picture of a drive shaft, and then so here's that slip joint. Here's your yoke right here, and that U-joint right inside there, the two yokes, and then here is the rear one that goes to the differential. And note that this drive shaft is hollow; they're not solid, and they're balanced. So here's another style. We got an external slip yoke right here, where this one before was an internal. This one's an external slip joint right there. And then here's that front yoke, and then here's a rear yoke to the differential. And notice there's two, double Cardan U-joint right here. This allows for more angle and a smoother operation, less vibration. And then if it's a really long drive shaft, you're going to have a center carrier bearing right here. And then here is kind of a close-up view of that center carrier bearing. And that splits it into a front and a rear drive shaft, so a two-piece drive shaft for like long bed pickup trucks, stuff like that. So rear wheel drive axles and differential. So now as we come through that drive shaft, we have to split that power flow 90 degrees. And then what's going to accommodate this, what allow that, is this rear differential unit right here. It also gives us a gear reduction, which is going to increase torque as it reduces speed. So that drive shaft's coming down, it hits that differential, it's going to increase torque and reduce speed through gear reduction, and then it goes out to the drive wheels here, left and right. We'll talk about how power gets to those drive wheels in a few slides. So why do we need a differential? Well, a long time ago you'd send power just to one rear wheel, but then of course that one rear wheel would slip and you'd be stuck. So they wanted to give power to both rear wheels, but the problem with powering both rear wheels, that as you turn a corner, your wheel speed is going to be different based on position, and that's because each wheel takes a different path of travel. So the further the inside travel, the further the inside path, the wheel is going to go slowest, and the further on the outside that you go, the wheel has to travel more distance, so it needs to go faster to keep up with the rest of the vehicle. So if you had a differential in the rear that didn't allow for differentiating speeds, it would just the wheels would skid as you turn around the corner. So the differential allows for differentiating speeds, hence the name differential, as you turn around a corner. But how does it do that? It's actually pretty complicated, but also really, really simple. And I can explain to you until I'm blue in the face, and you would just look at me if you could with puzzles, because that's how I was. And then I watched a video from the 1940s from GM, or 30s, I can't remember what year it was, and it made perfect sense. So after this part one, there'll be a link to that video from GM. It is a perfect explanation of how a differential works. But basically, as power flow is coming in, here's that rear U-joint. It's going to go here into this pinion gear. Pinion gear turns this ring gear. Ring gear is going to turn this carrier case, and that carrier case is attached to the axles via side gears right here, and that goes down to the wheels. But what the video will show you is how it accommodates different speeds as it transfers the torque to the two axle shafts. So again, here's a breakdown picture. Typically, like it looks like a Ford 9-inch has that front bearing on that pinion gear. This helical spiral pinion gear is going to come in and transfer power from the drive shaft. So the drive shaft comes in to the yoke, splined right here. It's going to spin this pinion. This pinion spins this ring gear. The ring gear again spins a carrier, so on and so forth. When you hear about gear ratios, like this one right here, this gear set's a 39 tooth and the pinion is 10. So we get to take 39 divided by 10, we get 3.9 to 1. What does that mean? Well, that means that this pinion gear has to spin 3.9 times for this ring gear to spin once. Hence the gear reduction. It's going to slow down, reduce speed, but also increase torque. So it depends what you want and with what gear ratios you want to achieve. I think freeway speeds are going to be lower in the 3 to 1 area, and rock crawlers are like 5+ to 1. You know, if you get real crazy, they could be way, way, way up there in the low gears. I know that sounds weird. Lower the gear, the higher the number, but that's because of the gear reduction. So again, 5 to 1 would be a low gear because it has to spin 5 times. This pinion gear spins 5 times to 1 ring gear. So super low gear. And then here's kind of another split away kind of look at this. As power comes in, it's got ring gears going to be bolted in right here where these holes are. And this whole carrier turns, which because of these side gears and the pinion gears right here, what you'll find is the whole carrier turns if the traction is equal on the wheels. As soon as one wheel's traction becomes unequal or it needs to change in speed, this setup of gears right here is going to accommodate that differential in speed, which you'll see in the video. Okay, so kind of again, here's that pin, and then you have these gears right here, the side and pinion gears in the carrier, and the video will totally make this make sense. So sometimes here you have this case. This is like a center section right here. That carrier goes in. Sometimes it goes into the actual housing where it's got the kind of mount right here. It's built in, integral into the housing. Or you can have a setup like this where you have removable carriers like a Ford and Toyota. So this is like a dropout or a pumpkin. The whole setup you can kind of see on this Toyota one right here. You can look. You can see basically right here where the axle comes in. This whole section can be unbolted from the axle housing, and then this is where the drive line comes in. This whole section comes out. It has that carrier set up and a ring gear pinion all in it, so you can set it up on a bench. Really, really popular among rock crawlers, racetrack folk, because it's easy to set up on a bench and you can drop it in, drop it out, hence the name dropout, versus this where it's more like a Dana setup or GM. This carrier, this case, it just goes into this housing and has a lot of work. You have to pull the axles out and take out the caps and a lot of differential setup, where with this dropout style, you can have it all set up at a shop and just bolt it in and go. If you want to change gear ratios or fix something, you can have a backup one ready to roll. So this is the point where I normally show this video and how this works. But what you're going to do is, again, after this part 1, click on this video and it's going to give you an idea how the differential works. Okay, so different style axles in the rear. You have semi-floating axles for rear wheel drive, and what this basically is you're going to see that the axle's outer end is supported by a bearing and the weight of the vehicle is on the axle. Okay, so here's another picture. So here's the rear axle, and you can look at this flange right here. Where you bolt the wheels up to this flange, that axle goes down through the housing and over this differential. The weight of the vehicle is on the, let's say the truck's up here, it's going to push on springs, which pushes on this housing, which is going through the bearing and then through the axle to the wheels and to the ground. Okay, so all of that weight transfer is going to be through the bearing and the axle. And this is called a semi-floating one. And they're held in by a couple different styles, kind of a retainer ring, like this one we see right here, which is, here's a real picture of that retainer ring. So here's this collar right here. This kind of retainer, as it's right here, see right there, the retainer. This is pressed on the axle, which holds this bearing in place, and it also holds the inner race of that bearing. And then here's a cover right here. You look at this picture, the retainer cover right here. That bolts onto the housing, and it's going to keep the outer race in place. So it kind of keeps that bearing from shifting, and it holds the axle assembly. Everything's kind of pressed together. Bearings pressed on the axle, retainers pressed onto the axle. This cover bolts onto the housing, and it kind of bolts everything in place. So if it bearing were to break, this axle could come flying out. And also, again, all the weight of the vehicle's on this axle, which can cause that bearing to break and the axle to break. So you won't see these on big heavy-duty applications, more light-duty trucks and cars, rear-wheel drive cars. Here's another style that they clip in for semi-floating. It's called a C-clip. So instead of on the outside having that bearing pressed in and the cover, you have the seal that keeps the gear oil in and the bearing. But what keeps the axle in, if you follow this all the way in, you can see the C-clip that notches into that axle and then the side gear, and it's going to help keep the axle can't come out because the C-clip is retaining it. So here's another picture of that, because I know that cartoon's not very clear. Here's a differential, here's the ring gear, here's a carrier, you have these side gears and then pinion gears, and this cross is in right here that actually transfers all the power to the carrier. So you'll see that in the video. Right here is the axles. If I take this pin out, it allows me to push the axle in and see the C-clip. It's in a groove. That normally is riding deep in here and you can't see it in that side gear. So the side gear keeps the C-pin in. The C-pin keeps the axle from going out. So in order to move the C-clip, you remove this pin, which is bolted right here. This bolt comes out. This pin drops out. You push the axle in. So this picture over here is now where we're at. And then you can slide the C-clip out, and then the axle can go out and slide out. So if this C-clip were to break, or this end of the axle were to break, excuse me, the whole axle and the wheel assembly would fly off. Now, by contrast, a full floating axle, as you see in this picture, the axle shaft is bolted in right here and it can slide right out. So you unbolt all of this and the whole thing slides out, which means the weight of the vehicle is not on the axle. So the weight of the vehicle kind of goes through this hub, basically, and the bearings are on the axle. So let me show you another takeaway here. So here's that axle slides out, the unbolt, and comes out. If you look at the hub, this flange right here, and all these bearings, they ride on the actual housing, right here. Okay, so the hub and the bearings go on the axle housing, and then they're bolted in. And then the axle shaft slides down this hole, which goes down through the axle housing to the differential. And that gears to the differential and then bolts to this hub. So it links it. So the differential's turns the axle comes out through the hub, goes through these bolts, and it spins the hub from the outside. The cool thing about this, again, is that you can unbolt the axle right there. Now all of this needs fluid, so there's a fill hole on the differential, and they want the fluid to not be too low, too high. This allows for splash lubrication without aeration, so that, and you want the fluid high enough that it carries on through the axle tubes all the way out to these bearings and lubricate these wheel bearings on the outside. This is a semi-floating setup right here, but there'll be a visible hole right here that you can check the fluid level. This concludes part 1, And when we come back on to part 2, we'll continue.